Hello everybody and welcome to video 4 in this Rust programming tutorial series. In this video, I'll be going over data types, specifically the primitive data types in Rust. There's a lot more data types that I need to cover, but I'm going to get to those in later videos. For now, we're going to look at the most basic ones, which are known as primitive. Now, before we dive in, I will mention again, I do have a programming course, programmingexpert.io. Check it out from the link in the description if you want to learn software engineering tools, software design, you want to learn how to program in Go and Python, and have a ton of interactive practice questions, assessments, and projects to work on. Thank you guys very much if you do decide to purchase that course. Again, link in the description. With that said, though, let's get into this content. So data types. As I was saying, we have primitive data types. Now, these are the most basic data types. We can kind of use them without having to do anything special. And that's really what the primitive data types are, just the most basic ones in a language. So that's what we're going to look at here. Now, Rust has two categories of primitive data types. We have a scalar type, and then we have a compound, or the types kind of fall into the categories of scalar and compound. Now, scalar simply means a single value, so something like an integer, something like a Boolean if you're familiar with data types. Whereas compound means multiple values, so here we actually have an array and we have a tuple, which we're going to look at in a minute. For now, though, let's look at the scalar data types and how we use those in Rust. So as we know, Rust is a statically typed language. That means it's very important for us to understand what type our variables are, and we can implicitly have the type decided, or we can explicitly define it when we declare a variable. So if I do something like let x equals 2, implicitly the compiler is going to say this is an integer. However, I can explicitly define the type by doing something like colon and then I32. And what this means is that I am assigning the type of integer 32 to the variable x, then I'm storing the value 2 as this type I32. So this is the first type, right? Integer. This stands for a signed integer that's using 32 bits to represent and store the number. Now, the number of bits essentially tells you how large of a number you can store and the range of numbers that can be stored in a variable. I'm not really going to get too much into binary here because that's beyond the scope of what I'm meaning to teach, but 32 is actually the default value for an integer in Rust. So what I mean by that is if I do something like let x equals 2, by default, the type of this variable is going to be I32. Because this is an integer value and we could assign it to many different types, but we default it to I32. Okay, so let's keep looking at integers. So as you saw, we had I32, this is the default, but we also have multiple other types of integers. We have I8, we have I16, like this. I believe we have I64, and I think we even have all the way up to I128. Now, again, these are the number of bits that's going to be used for all of these integers. And in case you're unfamiliar with an integer, this is any number that does not contain a decimal part. So any whole number, essentially, something like 8, something like -9, something like 9,727 negative. That's totally fine. And since we have a signed integer, that's just what the default integer is, that means we can use a negative sign for our value. Okay, so those are the different types for our integers. We then have the data type of uint. Now, uint is unsigned integer, and it's exactly the same as integer, except you can't use negatives. So if I do something like let x, and then this is u32, I'm saying that I'm going to assign this variable the type of unsigned integer 32, and then give it the value of 972. Now I can't assign anything to this variable that has a sign to it. Like I can't have a negative number here because this is an unsigned integer using 32 bits to store the number. Now, I don't want to get too much into binary here and the different ranges and all of that, but I'll just quickly mention that when we're looking at something like a U32 versus an I32, or we could even go even simpler with something like U8 and I8, these are able to represent the exact same number of unique values. So using 8 bits, you're always able to represent 2 to the exponent 8 unique values. However, the range of values that you can represent is different when you're using a U8 versus an I8. For example, with an unsigned integer, you don't have to represent any negative numbers. So the range of numbers you can represent is 0 to 2 to the exponent 8 minus 1. Because you have 8 bits, you put 8 here for the exponent, and this is the range. You can represent, I believe, from 0 to, this is going to be, I think, 128, or it's going to be, 255. My apologies, 0 to 255. That's the range of numbers you can represent with a U8. However, with an I8, this is going to change. Now you're going to be at negative to the exponent, and then this is going to be 7. You have to reduce the exponent by 1 to 2 to the exponent 7 minus 1. So with I8, you're going to have a range of -128 to 127 in terms of the numbers you can actually represent. Whereas this is going to be 0 to 255. Hopefully that makes sense. If it doesn't, then I'd say refresh yourself on binary a little bit, but I just wanted to quickly mention that. Okay, so we've looked at signed integers and unsigned integers and the different quantities. Of course, with U32, we have U64 with a lowercase, and we'd have U128 as well, if I spell that correctly. Okay, so that is it for integers. Next, we're going to look at floating point values. So in Rust, we have two floating data types. We have F32 and F64, and this means we're going to have a floating point value using 32 bits, and we're going to have a floating point value using 64 bits. This is also known as single precision and double precision. So let's have a look at one of those values. We could do something like let's go floating point, and then we'll say the type of this is going to be F32, and this could be equal to something like 10.9. So as soon as we have this decimal component here, now we know we're having a floating point value, and we need to use the F32 or 64 type. Now the default type, if you don't actually explicitly define it, is going to be F32 using single precision, okay? All right, so I think that's really it for floats. Those are the types, F32, F64. If you're not sure, just use F32. Now we can move on to Booleans. Now a Boolean is simply a true or false value or a 0 or 1 value. So for a Boolean, we could do something like let true or false equal, and then this can be false. Notice we have it with lower cases. There's no capital on the first letter like in Python. And this type here is simply the bool type. Now we also could make this a true, but these are the two values this could store, true or false. Now false is also represented by 0 and true is represented by 1. Sometimes you may see that, so you can also use 0 and 1 here. Again, 0 for false, 1 for true. Okay, so that is the bool type, not much more to talk about there. And lastly, we have the char type or the character type for our scalar primitive data types. So a character is going to be something like this. So let's say let letter. The type is going to be char, not character, just char. And then we're going to use single quotation marks here, and we can put any character on our keyboard. So char just stores a single character. We have 8. We could do, sorry, not 8. We have a. We could do 8. We could do 9. We could do a bracket. Really any character you can represent as long as you're using single quotation marks. Okay, so those are our 4 primitive data types. Again, we have int and uint. I'm kind of counting those as one, unsigned integer and signed integer. We have our floating point values with F32 or F64. We have our Boolean values using bool, and that's going to be true or false. And then we have our characters using the char keyword. And again, you don't need to manually define any of these if you don't want to. They will implicitly be set when the compiler is running through this code. Okay, so that's it for our scalar types. Now let's look at our compound types, and then we can just, I guess, print a few things out and do some examples here with the types to make it a bit more clear. Okay, so for our compound types, we have a tuple. I believe it's called tuple, not tuple. Some people, I think, say like tuple or some weird pronunciation for it, but it's called tuple, spelled like this. And we also have an array, okay? So a tuple is going to be a fixed length sequence of elements that is immutable. So to create a tuple, I'm going to do the following. I'm going to say let tup, standing for tuple, and then I can make this equal to my parentheses here, and inside of the parentheses, I can put whatever values I want. So I can do something like 1, true, and then maybe put a character in here like s. Now, the type of this tuple implicitly is actually going to be what I'm going to write out here, which is an I32, a Boolean, and then a char. So that's actually what the type of this tuple would be. Now, the tuple really is defined by what values it's storing. So this is actually the type, right? This is not a tuple. It is a tuple that has an I32, a Boolean, and a char as the 3 values. That's the specific type of this tuple. If I make another tuple here, so I do something like let tup2, and then I change this to something like I8, these are different types. These tuples are not the same type. I could not assign this to this tuple here. That would not work because these are different types, right? This is an I8 as opposed to an I32. So just keep that in mind. I know a lot of people get confused with this, but the actual type is reliant on what elements are being stored inside of the tuple. It's very specific. Okay, so that is the basics on a tuple. Now, tuples are immutable, just like all our other variables by default. You can, of course, use the mut keyword if you want to make them mutable, but let me show you how we access specific elements from our tuple. So what I can do here is something like println, exclamation point. And if I try to just print out my tuple here, you'll see that I get an error. So let me go here and Let's go back here and run this, and notice that I get some problem. Let me make this a bit larger. It's saying that print ln, okay, expected semicolon. Sorry, let me add the semicolon first just so that we're not distracted by that error. We'll rerun, and we still get an error here. And it is saying that we cannot format this with the default formatter. So it's not possible to take this type here and format that using this. So instead, we'll just print out individual elements. So to do that, I can do something like tup dot, and then I'm actually going to use the index of the element that I want to reference. So if I wanted to reference the first element here, I would use 0. I know this looks a bit weird, but tup dot 0, that's going to get me 1. If I wanted the second element, I would do 1. If I wanted the last element, I would do 2. The indices are just numbers representing each of our elements, right? So the first one's going to be 0, second one 1, and then the last one 2. Okay, but if I do tup2 here, we should see that we get s printing out. So let's clear and run. And notice that we get s printed out to the screen. If I do tup of 1, we should get true. So let's have a look at this here. And notice that I get true. Okay, so there you go. That is how you access the individual elements. Now, continuing with tuples here, let's have a look at how we can maybe mutate the tuple. So let's change this to be mutable. And now let's do something like this and actually just test if this works. So tup0 is equal to, and let's make this equal to 10, and let's print out tup0. Okay, so take a guess at what you think we're going to get here. Let's run the program. And okay, it keeps getting mad at me for the semicolons. I keep forgetting those. Let's run this again, and let's see. And notice that I get 10. So I actually am able to modify using the indices when I add this mutable keyword. However, if I remove the mut keyword and I go here and rerun, notice that I get a problem. It's saying cannot assign because this is not mutable. So using the individual indexes, we can assign to the value in the tuple. And then if I make this mutable, we should actually be able to change the tuple entirely as well. So I can do something like tup, and I can change this to maybe 10, false, and then let's just go with A. Okay, and let's run this, and let's see what we get. And notice that we get 10, and that is fine. Although it's giving us some warning here saying on by default, what is it? Variable assigned to tup is never read. Okay, so it's saying there's no point in us writing this, kind of like the warnings we were getting in the previous video. Okay, so that's pretty much it for tuples. There's some more I could show you, but I think that's fine for right now. One thing to note is that I can't add elements to the tuple, right? So if I try to do something like add a 10 here, this isn't going to work. I'm going to get an error because I'm trying to change the type of the tuple, and I can't do that because the type only contains 3 elements, so I can't add 4. Okay, that's it for that though. Let's quickly move on to arrays, and then I'll wrap up the video by mentioning strings to you, and then we'll move on to user input in the next one. So to create an array, I'll do something like let arr, and then this can be equal to something like 1, 2, 3, 4, 5. Now, arrays have to have the same element inside of them. So in this case, they're all going to be int 32 by default. And if I want to get index access here, I can do this similarly to the tuples, but this time we're going to use square brackets, and I could do something like arr0. That would reference 1. If I do arr4, that would reference 5, so on and so forth. Now, just like our tuples, an array's type is defined by the type of elements as well as the number of elements in the array. So unlike other languages, I can't actually add elements into this array. I would need to make a new array with a new type that has more kind of allocation or more space for different elements. Here, I'm only able to have 5 elements in this array, and they all have to be of the type int 32. Now, let's see if I can change this, doing something like arr4 is equal to 3. And then we might as well print this out. So print line, and we'll do our formatter here, and then arr at 4. Let's give this a test. So clear and run. And notice we get a problem here. It says we cannot assign because this is not mutable. So just like the tuple, I would need to change this to be mutable. Now, if I go back here and run this, everything is fine. And we're printing out 3 because we assign that to the last element. Now let's have a look at how we explicitly define the type. To do that here with our array, we would go colon, and then the type is going to be square brackets, the type in your array, so in this case, I32, and then a semicolon followed by the number of elements exactly that you have in your array. So in this case, we have 5. So if I run this now, let's go here and run, and notice that it works fine. We get what we need. Now let's just have a look at what happens here if we do something like this. So we define an array without actually initializing the value. So we're saying the type is I32. We're going to have exactly 5 elements. Let's see what happens if we try to access the last element here by running this, and notice we get a problem here. It says use of possibly uninitialized ARR. So unlike in other languages where you just get values automatically initialized in your array, that does not occur here. You do need to manually initialize it. And if I try to do something like make this equal to an empty array, we should get another compile time error here, saying that we can't assign an empty array to an array of type i32 with 5 elements. Okay, I know I went through a lot here. This video was actually a lot longer than I was expecting it to be, but I wanted to thoroughly walk you through all of the different data types here, the primitive data types, and show you how they work in Rust. Hopefully this gave you a general idea of what these data types are, how to use them, what values correspond with which data types. I did spend a lot of time, again, because this is very important. You need to understand the types before we move any further. Now, I will quickly show you that you have to be careful here with your types. So if I do something like let x and I make this u8 and this is equal to a 4, let's see what happens if I try to say let y equal x. Okay, so let's just see what happens if I go print ln exclamation point and we print out, and we'll just print out y. I'll also note you can print out multiple values, so I could actually do something like x comma y, and of course x will line up with that, y will line up with that. Okay, so let's go here. Let's clear and let's run, and notice this is all fine. Now I'm gonna ask you, what is the type of y? Well, some of you may say the type is u32 or i32, but actually the type of y is u8. And to prove that to you, if I change this to be something like i32, which is the default, you'll see that we get an error here when I run the code. And the reason we get an error is because we cannot convert this uint data type here to an i32, or the uint8 type just isn't i32. So I'm saying this variable is of type i32, and then I'm assigning a u8 type to this variable. However, if I actually put a 4 here explicitly, you'll see that I don't get any problem because 4 can be treated as an i32, but I can't use x, which is of type u8. So you have to be careful with how that works. You'll learn more as we go through and see kind of the features of a statically typed language, but I wanted to quickly show that to you. So with that said, I will wrap up the video here. I hope you enjoyed. If you did, make sure to leave a like, subscribe to the channel, and I will see you in another one.